All right. Hello, everyone, and welcome to part two of the PRM for October November 2020 O Levels Variant 2.1. Last time we left off, we had discussed what the actual PRM requires of us. We explained what task 1, 2, and 3 are actually meant to do. We looked at the emulator, which is how the program will look once it's finished. And we discussed the overall tasks and how each task will be performed from a superficial level without actually going into the code. And so today we will actually be going into the code. We will look at the pseudocode for tasks 1, 2, and 3. And we shall see how you can write it yourself, and we'll be explaining each what each part does. Pardon me. Okay, so this is the pseudocode for all three tasks. I will be explaining which part will be necessary for which task. So, for example, if you're asked to do task two in the question, if you're asked to write the code for task two, you will only have to write a bit of this. For example, this is where the code for task two is, and I'll explain this as we go along, obviously. But let's begin. So the first thing what we need to do in any program is we need to actually leave some space when we're writing any program. We need to leave some space for the variables. So obviously it's really difficult to know which variables you'll be using throughout the code. Most of the time when you're writing the code, you just think of variables and then you go back and declare them. So for that, it's always best to just leave space and then come back to that when you encounter a new variable that you have to introduce. So let's just go through these. Why they even exist will not really make sense yet, but it will as we go along. So just to give you a preview, we have a base price, which is going to be an integer. We have an engine size liter, which is a real value. Just a brief recap: a real value is anything including decimals. So 1.1 is a real, and any like whole numbers like 1, 2, 3, 4, 5, 6, etc., they're all integers. So engine size liter is a real. Price change percentage is an integer. The value in thousands is real. The location kept is string. There's one called location flag, which is a boolean. So a boolean is a variable that has either one of two states, either true or false. There's also a variable called 1,000 kilometers driven, which is real. Driver age as integer. Years without a claim as integer. Discount percentage as integer. New customer discount percentage as integer. New driver choice as string, and new driver age as integer. Again, we just went through these just for a brief overview so that you have in mind what these might have, and so that you can try to piece the code together yourself before we even start. But if they don't make sense, that's really no reason to worry. We will be discussing them as we go along. And then we also declare a new price as a real value. Here we have initialized all of these values. We have initialized the base price to 500, which if we go through the PRM right here, the base price, as stated, as we discussed in the last in the last video too, the starting price of the car is $500. So that's going to be the base price, which is $500. The price change percentage I have initialized to 0. The engine size liter is initialized to -1. All of these initializations will make sense when we discuss them throughout the code, so just bear with me for a few moments. Value in thousands is -1,000. Again, why we'll discuss later. Location flag is false. 1,000 kilometers driven is -1,000. Driver age is 0, and years without claim is -10. So it's always a good idea that whenever you introduce variables, whenever you declare variables, you initialize them to some value which is appropriate for that particular code. So here we have initialized all the values we have declared, apart from new price, I believe, but that will be done later when we calculate the actual values. So now this is where the actual code begins. All of this was declaration and initialization. The actual code begins from. I mean, that too is part of the actual code, but the part which fulfills the task requirements starts from here. So first thing we need to do, as we discussed last time, is task 1. Let's just go back through it again just for a refresher. So in task 1, we are asked to write a program to obtain the required information from a customer and calculate the price to insure the car, display that price to insure the car, display the total percentage change calculated from table 1 and the years without sorry, the years without claim discount percentage from table 2 separately. First things first, we need to write a program to acquire all the information. So this information, um, the engine size in liters, the value in thousands, where it's kept overnight, the 1,000 kilometers driven, and the age of driver. All of these have to be asked, have to be prompted. And when the user gives us the data, we have to then check which range it lies in, which range the user's value lies in, and then we have to update the price change accordingly. So you might have guessed already, there's going to be a lot of conditional statements because we have to check which range it lies in, and so that check has to be done by conditional statements, mostly if we will be using a case once. There's no requirement of whether you have to use if or case, but it's better if you mix both of them in there. Why not? So so here we have the conditional statements which will determine which range the price lies in. However, we need to loop this, and the reason we have done this is because what happens if the user enters a wrong value, right? So what if, let me just go back to the program. What if I say that the engine size is negative 10 liters? That's not possible. That's obviously a wrong value. So if I had just made this, if this was the only part for the engine size liter, then then all of these conditions would be false. So none of these would happen. It would output that please enter a valid engine size, and then it would just move on to the next part. But we don't want that. We want that until the user tells us what the actual value is. We keep going back. We keep going back through it. So let's see what happens if I say this. There we go. Right, and then it loops us back through it. So what happens here is that when we output a value that doesn't work, it goes back into this loop, and the reason is because the loop condition has been set as while engine size liter is less than equals to 0. So what's happening here is that before we even enter into the checks, what we're doing is that we're running an iteration where as long as engine size liter is less than equals to 0, we are going to run this. So two things that we need to notice here is that when we initialize engine size liter, we made sure that whatever the initialized value is, it fulfills this condition. So because while loops run on the true condition and repeat until run on false. So while this statement, this condition needs to be true for it to even enter into all of this in the first place. So if I had set this as engine size as 1, then it would never even ask the user to input. It would never update the price change, simply because this condition would be false. So it would ignore all of this, and it would come into whatever the rest of the code is. So that's why we need to make sure that this is negative, initialized to negative. And I hope that the initializations are starting to make a bit more sense now, at least for the engine size leader. And so we have initialized this to -1 so that this condition is fulfilled to begin with, and then we can enter the loop. So what's happening here is that once we do enter the loop, the first thing that happens is that we display a prompt to output the engine size in liters of fuel. So this is this message that is output before the user gives us any value. This is what's known as a prompt. So last time we discussed, if I go back into this, last time we discussed how the program must include appropriate prompts for the entry of data. So this is that part. This is the prompt. And then we are taking the input, which we are storing in the variable engine size liter. Um, and then once the user has input the size of the engine, and that is stored in this variable, then we just perform a number of checks and make sure that we know which range, according to this table, which range the values lie in, and then we can update the price changes accordingly. So if the engine size liter is greater than 0 and less than equals to negative, right, and less than equals to 0.5, then that means that this is this it's this range, which here it states less than equals to 0.5, but logically, obviously, you cannot have a negative like a negative engine size. It cannot contain -1 liter of fuel, right? So the lower cap is 0, and then for this range, for negative for the range where the price change is -5%, the upper limit is 0.5. So this less than equals to means that 0.5 is included. So we need to do the same here. So while engine size liter is greater than zero point 0 and it's less than equals to zero point 0.5, the corresponding price change is negative 5%. So we do the same here. So here what we're doing is that we have a variable called price change percentage, which we declared up here, which is also an integer, and we initialized it as 0. So currently the value of price change percentage is 0. There's no change in price because obviously we don't have any data. So as soon as we identify a range, so for example, if this range is satisfied, if this condition is satisfied, then this if statement will say, okay, this is happening, so let's go into this block, and then it's gonna run this command, or it's gonna like execute this line of code. So what happens here is that we are just totaling the price change percentage with this value. So what's happening is that price change percentage currently has 0. Where to go? 0. And now we are updating price change percentage to whatever the value was, minus 5. The reason we're doing minus 5, as you might have already guessed, is because it's negative 5%, is minus 5%. So the total right now, like if this was the only piece of information we cared about, then the total price change would be minus 5, and so we would apply minus 5 onto $500, and then whatever the value was, that would be the output. So for now the total price change is minus 5%. So that's exactly what's done here. However, if this condition is not satisfied, then it will come into the else if condition. So it will then check if it's in the second range given to us, which is greater than zero point 0.5 and less than equals to 1, which is this one. uh, Please note that here we have a greater than zero point 0.5, and here we have a 2 1. So what this means is that whatever the 2 thing is, that is included. So this value should be written as less than equals to, whereas this value should be written as simply greater than. And you might have guessed why that's the case, because if this was greater than equals to, then if I entered, let's say if the value entered was zero point 0.5, I'm just this is not part of the code, I'm just writing that as an example. If the value was zero point 0.5, then zero point 0.5 satisfies this condition and it satisfies this condition. So the algorithm would like run both of these, or like it would run this, but then it would be a wrong statement. It would be wrong code to include both of these values in two different statements. So that's what we're doing here. We need greater than zero point 0.5 and less than equals to 1. And again, if this condition turns out to be true, then we update the price change accordingly again, which is here 0%. So that's done. And again, if that's not the case, if that doesn't work either, then it will check the next range and update accordingly. And if that's not the case, then the last range is greater than 2.5. So anything above $3,000. So zero point 0.3 is less than zero point 0.5, so the value so the price change for this one is -5. So the total price change is 0%, -5%, so the total is -5. And so that's exactly what would have happened here. The initialized value was 0, and so here if we say that what did we choose? We chose zero point 0.7. So zero point 0.7 is in this range where the price change percentage has been added to 0, or 0 has been added to the price change percentage, same thing. So now the price change percentage still has 0. So next time we go back through and we say, for example, we went with zero point 0.2. So zero point 0.2 lies in this range. So the price change now has to be added to -5, or in other words, -5. So that's exactly what we're doing here. So we don't actually need to make different variables and then add them all together, because whatever is happening to the same variable, because in the end it all has to be totaled. So there's no point in having a variable for value in thousands percentage and engine size liter percentage, because all of those percentages have to be added up in any case. So that's what we're doing here. We say that, hey, you didn't enter a right price, so please enter a valid price. And then again, the only value that triggers this response is a value less than 0. So we're going to go back through here and we're going to loop till until the user enters a correct value. Next comes a bit more interesting part, which is the location kept overnight. So if you noticed, then here we had numbers and here we have a string. The only problem here is that this was from 0 to infinity, so there were as many options as you wanted. However, here there are only three correct options. There's only garage, there's only drive, and there's only street. So we need to make sure that the user has entered a value which is the same as one of these. Now we do that in a couple of ways. So the first thing we need to do, and I'll explain this in a bit, but let's just go with it for now, is that this time the while loop is run based on a boolean check, based on a boolean flag. And the reason might be obvious, because we can't exactly we can't just apply a range check here, because there is no range. What we need is a location flag where the value of the location flag is initially false. Why, I'll get to in a second. But so here we're doing the same thing. We are outputting a prompt, and then we are inputting whatever the user is going to write into a variable stored at location memory with the identifier location kept. So next thing we need to do is that we need to check which of these three options the user has entered. So if the user enters, for example, garage, that is the same as this. However, in pseudocode, we work when we're comparing strings, it is case sensitive, meaning that is this is recognized as a different word than this, which is recognized as a different word than, let's say, this, and so forth and so on. All of these are different words, so we need to make sure that we actually recognize that if the user entered this, I don't know why he would do that, but if he entered this, then that is the same thing as the user entering this. So an easy way to do that is to convert whatever word that the user has input into a corresponding word with all capital letters, and then compare that to the correct value in all capital letters. So what's happening in this line of code is that we are converting whatever is in location kept to all upper values using the function upper. This Then this, once it's run through this function, location so if this was what location kept had, so I know I'm going through it meticulously, but just to make sure everyone understands. So location kept would now, after it has been passed through upper location kept, it would now contain, one second, bear with me, it would now contain this, because whatever was here was converted to upper capital. So whatever was lower caps has been converted into upper caps. Whatever was upper cap, in this case A, just stays as that. So now location kept contains all capital values for whatever the string was entered, and now we just compare that with the string for with the capital letter string for each individual option. So if the uh, the the value that the user entered is equals to garage, then we say that I'll get to this in a second, but then we say that the price change percentage is the same as is the same as identified here. So -5% for garage, 0% for drive, and 5% 5% for street. So that's what's happening here. If the location kept if upper location kept is equals to upper drive, then we say that the price change percentage is 0, similar to here. Where to go? Similar to here. And if the location kept is street, then the price change percentage is +5. The reason we are using this flag is that we go about this in the way that if none of these conditions have been met, then location flag was never turned to true. So every time that whenever we come across a condition which is fulfilled and we go into the loop, we convert location flag into true, simply because now we are indicating that yes, we have indeed got a correct value. So if location flag is no longer true, is no longer false, if it's true now, then this condition is false, and so while will not run anymore. So it won't loop back through this um infinitely until because now location flag is true and while only runs on true condition, and location flag equals true is location flag equals false is false. That was a lot to explain. So basically, location flag equals false is the condition, and this condition itself is now false, which is why the while loop won't run anymore. So that's what that means, and that's why we have used a boolean variable instead of a range, because there is no range here. All right, so next up we have the 1,000 kilometers driven. So we say that we're going to come into these ranges and compare all of these. So same drill. This time, 1,000 kilometers driven is indeed a real value. So we once again we have a range. The wrong range is 1,000 kilometers driven is less than 0. So a negative number will trigger this response. Will trigger us coming into this block of code. And so we say that we output the prompts again, we take the value and we store it in this variable, which is the same as the one we compared earlier. And then we compare all of those, and then the corresponding price change percentages are added to whatever was previously summed. So again, if none of these conditions have been met, then we output a error message, and the only value that will trigger this is a negative value, and then when we come back up into while, then this is now true, and so we go back into this until the user enters the right value. Now here, things are a bit different, only slightly different, because the age is an integer, whereas all of these previous values were either string. Well, one was string and all the rest were real. So the fact that age is an integer means that we don't have to compare like 18.5, because 18.5 legally, I mean, you can be 18.5 if you're like 18 and 6 months, right? But legally 18.5 is still 18. So this time driver age is stored as an integer. So what we're doing is that while driver age is less than 18, so this is the wrong value. So you're not legally able to drive unless you're already 18. So if the driver age if the driver age is less than 18, then we come into this block where we um, ask the user to enter the age of the driver, and we input the driver age. One thing we should notice is that the initial value for driver age was 0, which is less than 18. So it will indeed enter this block in the first place. So then we go through all of these ranges. All of these ranges are inclusive. So 18 to 20 means 18, 19, and 20. So all of those three values. Similarly, 71 to 80 means 71, 72, all the way up to 79 and 80. So here we are going to be including the greater than equals to values instead of just greater than or less than. So they will be greater than equals to or less than equals to, and less than equals to. So we go through all of those conditions, and we check what the prices are, the price change percentages are. and then we add those to whatever the value we previously had. So and again, if none of these were fulfilled, I'm sure you know the drill. We enter this block where we say that please enter a valid age, because that is the error message that we have to give. Okay, so that is the first part of task one, where we have to obtain the required information from the customer. There are two things we have to display, which we will be displaying individually. We have to display the total price change calculated from price one, and we have to display the years without claim discount percentage, and we have to display both of those things separately. So what's happening here is that we will store this percentage in a separate variable, because we need to actually use that variable later on. We need that individual percentage later on, and we need to show that this is the value that was calculated from here. So for this, we are using a different value for the a different variable for the discount percentages, as we did here. So here we used price change percentage, but here we are using discount percentage. What's happening is that um, we initialize years without claim to -10, which is obviously you can't have negative years, so that's a wrong value. And so we enter into here, and then we say that while years without claim is less than 0, output the prompt and then input the value, which we store in the same variable that we checked. And then like I mentioned at the top of the video, is that you can use either case or if, it doesn't really matter. And so for this particular one, we have used a case statement. So we say case of years without claim, and if it's 0, then the corresponding discount percentage is nothing. If it's 1, then it's negative, then it's 10. So here we're not using 10, because we already know that this is a discount. So the fact that this means 10% means that it's going to be minus or subtracted from whatever the value is. So we don't need to specify in this particular case that this is a negative, that this is a negative value. So if it's 2, then 23, 30, etc., etc. And so we compare all of those, and we say that whatever the value is here, the corresponding value for the discount is here. So so next we come into the otherwise, which is the same, which is the equivalent of the else statement. So if none of these conditions were satisfied, similar to how if none of these were satisfied, then in the if statement we came into else. In the case of statement, we come into otherwise, and we say that this is our error message, where output please enter a valid argument. This is the error message. So again, we try to end the while loop, and if discount percentage is less than 0, if it's a wrong value, then it's gonna come back into this loop and keep doing that all over again. So here is where the additional code for task 3 begins, because task 3 asked us to add an extra driver, and then the prices are updated accordingly. However, we shall not be doing that just yet. We will skip this, and we will come into here. We will do this when we begin task 3 in a couple of minutes. But for now, to complete task 1, the next thing we had to do is that um, we had to calculate the price to insure the car. So that's done here, where the new price is equals to the base price plus the percentage change in the price times base price. So what's happening here, why we're even doing this, is that whatever the percentage change is, that percentage change is the change from the base price. And so what if there's a positive number or a negative number, it doesn't really matter. We just add that to the base price. So if it's something, if the price has been changed to something less than 0, if it's negative, then adding a negative number simply means that we will be subtracting it from the base price in any case. So it will work. So this part, the fact that this is a add, will work perfectly no matter what. So this part, what this calculation is doing is that we say that whatever the price change percentage is let's say it's 40%. So all the way from here, we have price change percentage now contains the number 40. So if it has the number 40, then what it does is that it says that where to go, it says that price change percentage equals to 40 divided by 100 multiplied by base price. So that is 40% of base price, and so that is then added to the base price, which is 500. So 40% of 500 plus 500, that is your new price for the value of the car. And then since we have a a discount percentage depending on how many years it has been without a claim. Then we add these values, or rather we subtract the percentage of that from whatever we have calculated as the new price. So the new price is equals to new price minus the discount percentage into new price. So what we're doing is that we are applying the discount on the new price, and then whatever that value is, we're subtracting that from the previous value to give us the actual new value. I hope that made a bit of sense. So next we say that output the total percentage change in the base price of your insurance is and so basically what we're doing here is that um, we are displaying this, and then we're displaying this, and then we're displaying this. So this means that what this is going to output is that the total percentage change in the base price of insurance is whatever value is stored in here and percent, because this variable stores a number. So just for formalities, because it's actually a 40%, 50%, whatever, uh, a total change percent, we will show that by concatenating that with a percent sign. And so the next thing we need to display, as said here, we need to display the total percentage change from table 1 and the years without claim discount. So we say that the percentage discount due to the years without claim is discount percentage and percent. So discount percentage, whatever value we discovered from here, that is then shown that this is the percentage discount. And so that completes task 1. Oh, and yeah, we also show that the price to insure your car is the actual new price. So this is the additional code we need for task 2, and up here was the additional code we needed for task 3. So this can be ignored um, along with all of this if you have been asked to write the code for task 1. So everything we have discussed up till now was the complete code for task 1. Now we shall discuss the code for task 2. So it's actually quite simple and quite short, because the only thing we need to do is that we need to check if the customer is fits the description of a new customer. And that description is that if the customer is aged between 26 and 70, and they have a like a greater than 2 year for this value. So if it's 2, 3, 4, 5, whatever years without claim, then we apply a 10% discount to whatever the value was. So um, once we have, oh, and do take note that here we're not actually we're not asking for the data again, because all of that data has already been stored. We have individual variables that have all of these individual that have the values for all of these individual factors. So we don't actually need to go through that again. All we need to do is compare the driver age with the range that we are given for application of the new discount of the new customer discount. So 26 and 70 inclusive means greater than equals to 26, less than equals to 70. The equals to means that these are inclusive. If this condition is satisfied, then we need to make another check, because because both of these conditions have to be satisfied for the new customer discount to be applied. So if the age is between 26 and 70, and they have a 2 or more years without an insurance claim, then we need to apply the 10% discount. So we say that if driver age is greater than equals to 26 and driver age is less than equals to 70, so that's the first condition. If that is satisfied, then we again check this. So this is what's known as a nested if. So nested just means that it's an if within an if. So then we're checking that if years without claim is greater than equals to 2, which is this part, 2 or more years. So 2 or more is greater than equals 2. Then this means that both of these conditions have been satisfied, and we need to go into the new customer discount percentage, which is equals to 10%. And all of this is done. And so we say that the amount of money saved. So the requirement of task 2 is display the amount of money this would save. So we say that the amount of money saved by applying the new customer discount is, and then we concatenate that with this value, um, which is the new price multiplied by the new customer discount percentage. So if, let's say, this was 10%, which it would be, then 10%, so this is either 10% or 0 if none of this was satisfied, because we initialized that as 0. So it would be um, it would be new customer discount percentage divided by 100, which is basically 10%, multiplied by the new price. So the fact that we have written this like this is doing two things. For example, if this condition is not satisfied, then the new customer discount percentage is zero. So because the only reason that this that they would get the discount is if they satisfied both of these conditions. So if this was zero, then this entire thing, because we're multiplying with zero, then this entire thing would be equals to zero, and we would just have the output that the amount of money saved by applying the new customer discount is zero, is 0%. So or $0. Sorry. Like the fact that we have written it as this arithmetic statement means that this satisfies both conditions, whether or not the discount is applicable. So then we say that the new price, then we just go ahead and calculate the new price, which is the new price equals new price minus the new customer discount percentage times new price. So what's happening here is that we are applying this percentage. So basically we are repeating this calculation right here, and then whatever this percentage was, excuse me, whatever this discount was, we apply that discount to the new price. And the fact that it was a discount means that the price is being subtracted. So whatever this price is, we are gonna minus it this time. And then we have the new price value. That is the code for task 2. That's all the additional stuff that's required for task 2. The next thing is task 3, where we have the liberty of adding an extra driver, and we have to see this line of the PRM, which says that the age of the extra driver may increase the price. So then we have to check what the age of the new driver is, and then basically we're going through all of this again. So we did this once in task 1 for the initial driver, then we have to do this again for the new driver, and we have to apply this change in percentage to the overall price. So I believe that's all they're asking. The new price is calculated by applying the percentage price, and now we have to extend the previous tasks. So task 1 and task 2. Task 2 is an extension of task 1, and task 3 is an extension of task 2. So basically what we're doing is that before we actually carry out all of this, we now also need to run through this code, which is the additional code for task 3, which just enters a new driver and updates the price change percentage according to that. So here we are going to be reusing the price change percentage variable, which we used all the way up here for the first task. We're going to be reusing this because whatever we are adding has to be added to the overall price. So if they're adding a new driver, that affects the overall price in the first place. So we don't have a new price on which we then apply the percentage. We just calculate the new price according to this percentage. I hope that made sense. So what this basically means is that what we're doing is that we are outputting, would you like to add another driver, so yes or no. So this is the prompt, and if and then we are taking the input that the customer gives us, and we are storing that in add driver choice. If the value that they entered when run through upper add driver choice, if that is equals to upper y, that means that either of these conditions were satisfied. So either the user entered y or capital Y. In any case, they both mean the same thing. They both mean that this condition has been satisfied. So we do the same thing we did for the garage street drive statements, and we convert it into upper, and we compare that with y. And if this is satisfied, then now we introduce a new variable which we had initialized all the way up here, the new driver age. Then we introduce this variable, and we say, where is it, here, and we say that the new driver age is initialized to 0, and we say that while new driver age is less than 18. So basically what we're doing is that we are doing the exact same thing we did up here. However, this time the only difference is that wherever we had driver age, it's now new driver age, because driver age contains the age of the initial driver, whereas a new driver age is the additional part for task 3. So if you notice, then this thing is the exact same thing as above, except that except for this part, which is new driver age instead of driver age. So that updates the prices accordingly. And so once that's done, we now have the total price change percentage, and after that we calculate all of these things accordingly, and we output the new price. And that is it for the PRM. That is the entire program. So if we go through it again using the emulator, I'll show you what it's actually doing in the background. So if we go all the way up here, just give me a second. So the first thing it does is it initializes all of this in the background. We never see any of this happening, obviously, because we are not outputting any of this. So the only thing we are outputting, or the first thing we are outputting, is the prompt to enter the engine size in liters of fuel. And so, and then we're going to take the value of the engine size liter. So this is the prompt, and we say, I want to satisfy the condition one. I want to satisfy this condition where the price changes 5%. So let's say I'm gonna take 1.5. So 1.5 is greater than 1 and less than 2.5. So I say 1.5. And so what is done in the background is that it has actually ran through all of these. It ran through this one, and this condition was not satisfied, so it went to else if. This was not satisfied, so it went into this one. This was satisfied. So now in the background, the price change percentage, that variable has been updated to whatever the value was initially, which was 0, to 0 plus 5. So now price change percentage now contains 5. We can't see any of that here, obviously, because this is the display. So but in the background we have had the update of this variable. So the next thing it does is that it successfully exits this loop, and it says that while value in thousands is less than 0, so it now enters this one. And let's say I enter my car is worth let's say $21,000. So 21 is satisfies this condition, so the price change has been updated to whatever it previously had plus 15. So now the total percentage change in price is 20%, because it had 5% which it added from here, and then to 5 it added another 15, so that's 20. And so now it asks me for the next thing. So here we can actually see that if I enter, let's say this, that does not matter, because that is the same as upper drive, because it has been converted into upper. And so now what it has done is that it has turned the location flag into true in the background, and it said that the price change percentage has been added to nothing, because here, if you had it in the drive, then the price change was 0%. So once that's done, it enters the next condition, which is the 1,000 kilometers. So let's say I drive 18,000 kilometers. So that is this range. So the price change percentage is again 0. And then it asked me to enter the age of the driver. Let's say 20. And so it does all of this. Now what is done, now what it's doing is that it goes into this condition, or this factor, which is the years without claim. And let's say I have had 3 years without a claim or insurance. Now, because this is running in unison, because we are running the emulator as all three tasks at the same time, this is where task 3 begins. So it asks me if I would like to enter another driver, and if I say yes, so small y, capital Y doesn't matter, it doesn't make a difference, because we are converting that into upper. So if I say yes, then it says enter the age of the second driver. So if I say 19, then what it has done, so here like all of this, there was a lot of work that happened before the output, but again, the only thing we're outputting is the output statements, not this one. We are outputting the output statements, so that's the only thing we see. But what it did in the background was that it took this value that I entered, it took that into the new driver age variable, and it compared that variable, the value in that variable, to the ranges present in these. So if it was this one, then the price change is 100%, etc., etc. You know the drill by now. And after that, it just calculated the new prices, and then it output that. Um, so that's what's been done here. And then after it did that, it calculated the necessary things for part 2. And once it did that, then it just output the final price, which is 770, which if we go back through the tables and we add up the percentages and we apply that to 500%, that will be the same value that has been output. So we know that the program is working correctly. So that is it for the PRM for October November 2020 variant 2.1. This was the pseudocode of it. We have in the previous video we went through the actual task, and in this video we went through the pseudocode and what they mean and how we're going to go about them. Um, and so now you should be well equipped with the understanding of how you're going to write the code if they ask for any task. So if they ask for task 1, you write all of this, ignore the additional tasks ignore this and ignore all of this, and then you just output the price. If it asks you to write the task for task 2, you will just extend the task 1 by writing this. And if it asks the code for task 3, then this is the code for task 3, and this is what you write. So yeah, that is it. And I hope you have a deeper understanding. And if there's any questions, feel free to ask in the comment section down below. So thank you for watching.